have the differential equation y prime prime minus 2y prime plus y is equal to e to the t. So the second derivative of y minus 2 times the first derivative of y plus y is equal to e to the t. I have the initial conditions y of 0 is equal to 1, y prime of 0 is equal to 0, and I want to solve this differential equation using the Laplace transform. So I take the Laplace transform of both sides. I get s squared times capital Y minus s times y of 0 minus y prime of 0 minus 2 times in parentheses s times capital Y minus y of 0 plus y is equal to 1 over s minus 1. So this 1 over s minus 1 is the Laplace transform of e to the t. Now I use my initial condition, so minus s times y of 0, I simply get minus s because y of 0 is 1, minus y prime of 0, y prime of 0 is 0, so I get 0, and yes, minus y of 0, I simply get minus 1. Now I have minus 1 times minus 2, because this is in parentheses here, so I get plus 2 here. And I get minus 2 times s times capital Y, and I get minus s here, and here I get s squared times capital Y. So capital Y is just the Laplace transform of y, just for information. Yes. And here I still have my capital Y. So now I solve for capital Y. I get 1 over s minus 1 to the third power plus s over s minus 1 squared minus 2 over s minus 1 squared. And I can do partial fractional decomposition with this s over s minus 1 squared, and I get 1 over s minus 1 plus 1 over s minus 1 squared. And this 1 over s minus 1 to the third power and this minus 2 over s minus 1 squared, they still are the same. And so now if I take the inverse Laplace transform of everything, I get t squared times e to the t over 2. So that is, that I say no mistake, that is this part here. This minus 2 times t times e to the t, that is this part here, so this minus 2 over s minus 1 squared, this 1 over s minus 1, that is simply this e to the t, and this 1 over s minus 1 squared is simply this t times e to the t. And so I can rewrite everything as e to the t times in parentheses t squared over 2 minus t plus 1. Yes, and that is my final result. Yes, sorry.